Okay, hello everybody. Sorry for the late video. I know I said that I would have done this earlier, but grading has happened and also my other school stuff. So we are doing it now. So basically, people who submitted the worksheets until when I post or up until I post this video and post it on Google Classroom will get the slight extra credit for this worksheet or for the classwork and also um, the homework as well. So with that being said, here we go. Like I said, I will go step by step for each problem. How much detail I will go, I am not sure. So let me just start with color coding this right here. I will use I guess it will I guess my color coding will depend on this scenario. I hope you guys will be able to follow along. I need to see how zoomed in. Yeah, no, I have a really funky setup. I really hope. Yeah, no, this is gonna be okay. Well, this is gonna be an interesting learning experience. It's been a while since I did a video. Hold on, let me actually clean. I should have done this earlier, but let's hope I did not just make the camera worse. I can't even tell if you guys can read. Yeah, I'm not sure. I really hope you guys will be able to see this, because otherwise this is going to be a really bad time. Hold on, let me adjust it. I should have adjusted earlier, but we're adjusting now. I really hope you could see that. I hope you could see that this is 1 over n. I am looking at it from another monitor. It looks like it is. You might need to watch this on a bigger screen than on a, like if you're using a phone. So let's just get started. Enough delay because I just wasted basically 3 minutes. And I don't want to restart the video, so sorry. Okay. Notice, I want you guys to notice there's always a 1 for the exponent. Whenever there's like a number, there's always an imaginary 1 in front of any type of number. So say that if you were to do y is equal to, you don't have to write this down, y is equal to 3. There's always an exponent of 1 because there's 1, 3 there. So there's an imaginary 1 right there, even though it didn't show that there was a 1, but it's implied that there is a 1 for our exponent because there is 1a. Notice how the 1 from here goes was the inside, and then this is called the index, and it goes 1 over n. The exponent, the exponent is the numerator, and then the denominator is the index. Now, we're just going to be constantly using this form. I will use let's see, I wonder if I should use a color for this part. There's going to be extra coloring. I don't really want to do the extra coloring. Well, they're all 1s in this case, so I don't have to do it. So I'm going to be lazy. It's okay being lazy. Everyone's lazy. Okay, I'm going to be consistent. I'm going to be color coding the entire, so I don't have to be constantly switching over. I'm just going to be showing you the pattern. I should write this one down so you can see. Now, let's get started. I don't read. Or you could do this in your head, but I don't read it like this. I always read it as a radical. I don't like. I know the calculation for this because it's straightforward. But whenever I look at this, I always think of in radical form, which is this. I'm going to leave this because when you leave the square root, it's an implied 2. You do not need to write down 2 like this. If you do this, this is not wrong, but people might look at you funny. They might think that, oh, okay, that's weird. Okay, whatever. Okay, but technically not wrong. This is exactly the same. This is an implication of that there is a 2. It's just it's a common math agreement that everyone has agreed to, that this square root means that there is an index of 2. Hold on, give me a second. Hold on. Something's up, but hold on. Give me a second. Okay, sorry for the interruption. But yeah, there's this implication of a 2 whenever or for the index is a 2. It's implied. Also, I never actually explained the inside. This is, this symbol, the square root, or it's technically not square root. It's called a radical. It's just a little symbol. This little symbol, it's a radical. And then the number, or in this case, the letter, I'm just going to draw a little arrow. Hopefully you guys can see. The number inside, it's called a radicand. And then it's usually an N here. Usually, it could be anything. This is called index. It's just like a little notation. So the number in this case it's a letter. The number outside is the index. This little symbol, or we usually call it the square root, or squaring or whatever. It's called the radical, and then the inside is called the radicand. That's just a little math thing. But okay, let's get back to the problem. Sorry, I go on deviation. Hopefully I don't do that again or constantly do that, because it's 8 minutes and I've only done one problem, so gotta pick it up. Okay, I just want you to see the notation. Now, what is just the square root of 9? It's just 3. What does this mean? Is basically what two numbers, when you multiply them together, gives you the number inside, in this case the radicand. So if you multiply 3 with itself twice, you get 9. So this is actually the answer right here. I would like it if you box your answers, but you know. Okay, now let's go. Actually, I wonder if I should do this side. No, it's should I color code it? Yeah, sure, might as well. I'll make a note of it at like 8:20 or something like that, or I'll make a note of it. Hold on a minute, so you guys don't have to watch that little interruption, because this is going to be a long video. But that is just the way it is. Okay, 16. We're switching. We're constantly using this form. We're switching from here to here. You do not have to do that, but I always like seeing what it's like. In this case, it's just, I'm gonna just do the just a square root of 16. So just Makes it easier for me to see. And what is the answer? Square root of 16 is 4. I'm going to color code. Actually, I should just leave it open, because I'm constantly going to be. Hopefully I see that. Okay, that's it. So the answer is just simply. Is this a different? This looks different, a different color. I don't know if you could tell. Sorry, I got distracted easily. Okay. Over here, same thing. We're just square rooting 25, which is just simply 5. There you go. I really hope you guys can see it's not that blurry. I'm gonna try to adjust it, because this is in a weird angle. Okay, we got 27, and this is called a cube root, because why? Because it's 3, cube 3. It's the name. Okay, I'm gonna highlight the number 3 with orange. I hope you guys can see this. This is gonna be bad. Sorry. First video, it's not gonna be the best, but you know. Okay, now for this is a cube root. Basically what's happening here is, since this index is telling you how many times you need to find a number, when you multiply it with itself 3 times gives you 27. So we need to find what number, when we multiply with itself 3 times, gives you 27. And in this case, it is just simply 3. I'm going to use my favorite calculator. This is my favorite calculator. 3 times 3 times 3 is 27. So, but what this calculator can do is, I like to see visually. This is what's happening. 27. And then if we want to use a cool notation, oh, look at this. This is really cool. There you go. Boom. See how it's exactly the same thing. This is why I like this calculator. One, it's easy to see and read and use. So I recommend you guys getting this calculator. This is my favorite calculator. Of course, on the quizzes, on the tests, I'm not sure if I'm going to be using this, but it's gonna be very simple numbers where you could do easily. It will not be these big numbers. I can tell you that. Or I could split it up to bigger numbers and you're able to use a calculator. But it's up to you guys. I might ask you guys on later. Okay, switch it. 125 for the radicand, and then the index is 3. So color coding. Boom. Okay, we gotta find a number when you multiply it with itself 3 times gives you 125, and that answer happens to be 5. So we can just confirm that. 5 times 5 times 5, there we go, is 125. Perfect, we got it. Now, next one. This is a little bit tricky. Notice how there is parentheses on the outside. This is very important, that tells you, because you can easily mess this thing up. Okay. Don't forget the negative, it's on the inside. You're doing a cube root of negative 125. And this is what it is. There you go. Okay. Now we gotta find a number when you multiply it with itself 3 times gives you negative 125. I'll just give you a hint if you can guess the number. I don't know what the number is. You can guess. Okay. If you guys got the hint, it's negative 5. Now this is going to be kind of annoying to write down, but I will just show you. Negative 5 times negative 5 times negative 5 is negative 125. Perfect. You got it. Oh, I should be boxing my answer so that you guys will be able to see. What I'm showing is perfectly, like, this is really good work, I would say. This is perfect, but I technically didn't ask you to switch it, so you can just technically just give the answer. But, you know, it's better to show the whole process. Okay, now we got 81. Okay, here we go. 81. The index. Okay. Okay, now we gotta find the number when we multiply it with itself 3 times, or 4 times. I misspoke, sorry. 4 times with itself, we get 81. Now we're gonna have to do a lot of guess and check, but since this is just a little worksheet, you can just try it. Just try, plug and chug. Let's just try 2. 2 times 2 times 2 times 2. Is that? No. Okay. Well, let's try 3. 3 times 3 times 3 times 3. Oh, look at that. We got 81. It is 3. There you go. Actually, I should just color code this since it's already there. I know I didn't do that during class, but might as well. Just so you can visually see it. Oh, I forgot to do this one. Made a mistake there. Okay. I didn't do it over here, but yeah, we constantly do the same thing over here. In this case, we're doing, you know, what we kind of discussed in class. I don't want to repeat myself. Okay, let's go back to problem 5. I gotta make sure I remember the times because I don't want you guys to be watching. Well, I guess you can skim through to wherever section you want to go to. Okay, now I hope the audio's going. Yeah, it is going. Okay. Color coding is your friend. So I'm gonna keep it consistent. Oh wait, no, this uses blue. Okay, this is gonna be different colors from up here. So just keep in mind the color combinations. These are the color combinations. This is because I messed up. I used blue because I didn't color code it and I accidentally used the wrong colors. Okay, so I'm gonna have to use my blue. So what I did was, okay, I put the M as blue. I put the index as pink. Hopefully I just didn't just mess all that up and you can visually see it. Again, you don't have to do it. I'm not going to color the red again, but yeah, it's up to you. It's less work for me. Otherwise it's going to be a long video. Okay, so just to keep it consistent. Okay, I'm just going to color everything so I don't have to, it's less work for me right now. Constantly switching back and forth, just so you can see. There we go. Okay, we got all the m's, the numerator, exponent. Okay, and then now we gotta get right here the denominator. In this case, it's the n. This is the index right here. Okay. Now, of course, you can just plug it into a calculator and just get your answer, but let's try to solve that. I know these are big numbers, or it's not going to be big numbers on the test. Okay, now, let's go. There is 32, and then square root 5, and then 4. Now, I'm going to actually do it a different way so it actually deals with less numbers. Notice how we, or in this case, we did the exponent. We did this rule right here. Actually, we kind of did it differently. Oh, I think we're going to see it in a different... yeah, I did it differently. Okay, there's like a... Later on, you're going to see a different notation. Okay, let's do the radical first. Like, let's do it from here. Transition this to here. Instead of doing this to here. Because if we're doing this, it's going to be a little bit more complicated. We get bigger numbers. And I don't like dealing with big numbers. So, or in this case, I'll show you what I mean. Well, actually, I kind of messed up already, but I can't do anything about that. So I'll do it this time, and then the next one I will show you what I mean. Okay, because you would have to do 32 times 32 times 32 times 32 equals this really big number. I don't know about you, but I can't figure out a number when you multiply it 5 times gives you this number. So I'm actually gonna scrap this idea. I'm not even gonna try it. No, I'm not even trying. I'm just gonna scrap this idea. This is when you know this notation is not so good. So it's better that we should use this one. This one will make it a whole lot easier. Watch very carefully. We do the same thing, 32, but in this case we're doing the entire thing, which is, not sure if you can see that. This is the index is 5 right here, and then this is 32. It's not that good. Gotta constantly look at it. Okay, let's do it this way. This way is gonna make it so much more easier. Oh, that I just messed up that. Okay, this is the 5. This is horrible. Oh my god. Whoops. That's a yikes. Okay. Okay, what number when you multiply it with itself? Let's go to the inside. This is a 5. This is really bad. Okay, well, this is a 5. The index right here is 5. Okay. What's a number when you multiply it with itself 5 times gives you 32? Okay, well, 1 is not obviously it. So let's just do 2. Let's try 2. 2 times 2 times 2 times 2 times 2. Boom, it's 2 in fact. So the inside is actually 2. And now we just raise to the 4th power. Boom. That's how we got it. Okay. Now what's 2 to the 4th power? Can you do that in your head? 2 times 2 is 4. 2 times 4, or actually I should keep track, or I should just keep saying 2 times 2. Okay, let's count how many 2's are we doing. Okay, so we don't get lost. I'm not sure if you guys can do it in your head. I can, but just, you know, whenever you want to do this in your head so you can keep track of how many times you're doing 2 by 2, because sometimes people mess up on counting. Either they overcount or they undercount. Okay, 2 times 2 is 4. Wait, let me ask you, how many 2's do we use? We use 2 2's. So 2 times 2 is 4, so we use 2 of them. 2 times, or 4 times 2 is 8, times 2 is 16. So 2 to the 4th power is 16. If you want to do your calculator, you know, sometimes you want to check, do that, boom, there we go. Now, the other way that we had, remember that number that we needed, like that really big number, 32 to the, what was it, 4, yeah, 4, it got this really big number. Look, if you do 16 times 2, or actually, whoops, 5th, oh, I forgot the number, okay, well, 16 to the 5th power is the same number. I wanted to square root, or not, actually quint root. I'm not sure. It's the index is 5. I'm not sure what the exact name is, but it doesn't really matter. I wanted to square, or not square root, but do the radicand and then put the index as 5. So that's a horrible way. Imagine trying to figure out this is actually the number. So this way, it's actually better to start this way instead of doing this. So I'm gonna do this way, so it makes it easier for me to do the calculations. 32, do the radical. This will be a 3, this will be a 5. The index is the 5. Oh wait, I just messed up. And I messed up over here too. Oh my. Yikes. Again. First time. Sorry for the mistakes. Oh my god. That's really bad. So I'm gonna do the entire thing to make it easier. So we're gonna cube the entire thing. So what's a number when you multiply it with itself 5 times that you get -2? I'm just gonna give you a hint. It should be something related. If you got my hints, and if you actually did it, it is -2. When you multiply -2 with itself 5 times, you get -32. And then, but don't forget that you need to cube right there, or that. Keep switching the colors. Sorry about that. But you have the exponent. Oh my god, that just made it worse. This is negative. Yeah, that's just made it worse. Okay, so we got -2 to the 3rd power. So we got -2 times -2 is 4, +4, and then you do +4 times a -2, that is -8. No, I should really box my answers. Oh man, this is gonna be a long video, but you're welcome, guys. Everyone. Okay. Okay. I'm doing the easier way. Keep mixing up my colors. I'm pretty sure you're seeing the pattern. I wonder if I should even taught. Okay. Well, what number, when you multiply with itself 4 times, gives you 81? The answer is 3. If you want to actually pause the video whenever, I should have said that at the start. But yeah, if you want to pause the video, you can just pause it and then try to do it yourself and try to figure it out. That's the best way to learn. And then yeah, you know. Now I can't do this in my head. 3 to the 5th power, you know, I don't really know. I only know to the 4th power, but I guess you can just, you know, do it slowly and or you know, or at least I know. Okay, 3 to the 4th power is 81. That's what I do know. Okay, so that's. But we need one more power to make it the 5th power. So we need 3 times 81. Can you do 3 times 81 in your head? You could pause the video right now in order to do that calculation. I'll give you 1 moment. Okay. It's waiting. Okay. It is 243. Hope you guys got that. If you have any doubts, you know, just put in the calculator. But use your brain. Brain is a very powerful machine. Okay. Now, just keep in mind, wait, oh, I'm supposed to give you guys problems to do. Okay. You know what? I'm gonna let you do number F. Yeah, I'll let you guys do F. And then, oh, sorry, my lighting just went off. There you go. I got a ring light, so it makes it easier. I'll let you guys do F and G. I'll do that, yeah. Yeah, I forgot that I was supposed to give you guys homework problems. I'm going to be doing this entire thing. I just remembered right now. Okay. So we got negative 8, 3, and then 5. I should really use a different color. I'm not sure if you could read that. Okay. Okay, what number, when you multiply with itself 3 times, gives you negative 8? It will be negative 2. Now, if you don't believe me, if you do negative 2 times negative 2 times negative 2 is negative 8. Oh, see, this is why I say, like, sometimes you do a calculator mistake, and say that if you were to do it by hand, like, you would make a mistake. Oh, it's 8, okay. And then you just, that's a wrong answer. So sometimes the calculator can actually mess you up by either you just, like, misclick and make a mistake or whatever, that's not good. Okay, so we got negative 2 to the 5th power. Negative 2 multiplied with itself 5 times gives you what? You can pause the video. I'm going to write negative 32. If you don't believe me, make sure you put the parentheses. Negative 2 to the 5th power is negative 32. You got it. Okay, so I'm going to let you guys do, I should make a note of it, F, or actually, well, it's going to be on the paper, so it should be fine. F and G, that's what you guys are going to be doing. And then, let's see, let me actually pick out the problems, which one I want you to do from problem 6. So I remember, I'm going to make you guys do C, and then F. Yeah, okay. Keeping it consistent. There is an imaginary 1 always here. Sorry, I burped. I just ate spaghetti. I got this like pasta from Little Italy. It's really good. It's over in downtown. I'm not sure if you guys been to Little Italy. If not, I recommend it. Okay. Now, we gotta rewrite this from radical form to exponential form. This, I should actually write this down. Okay, up here, I should write it down immediately. Okay, exponential. And this is radical. There you go. I should write down form. I'm not sure if actually they call it. Yeah, no, I guess it just, okay, radical form. Okay, I guess it depends on how you say it. This is radical form, I guess. Well, they just call it radical. I'm actually don't know the exact term, but I guess that's just, semantics. It doesn't matter. Anyways, we're going from a radical to an exponential form. So there's an imaginary 1 here, and we are going to be using this. So we're going from here to looking like this. You see how this blue is on the numerator, and then this pink right here is on the denominator. The index becomes the denominator of the exponent, and then the exponent of this is the radicand. Remember the name up here, the radicand. Or in this case, it'll be this is the base. It depends on how you, because in the exponential, this is called the base, and it'll be in the radical form. This is actually called the radicand. So it's different names. I don't know, but who cares? I'm not gonna be judging you on a vocabulary quiz on a math class. No, not really. But yeah, okay. See how the exponent right here, in front of this number, or in the a, becomes the numerator of the exponent. So since there's a 1 right here, we go x. We don't change the number, or in this case, the letter. This becomes the numerator and this becomes the denominator. I'm gonna color code it. Oh, it bleed through. Oh, damn it. Yeah, this is horrible. Okay. I am sorry. This is a 3, and this is a 1. Yeah, damn it. Actually, I'm not sure if I'm supposed to say God, but yeah. Damn it. Or gosh darn it, I think that's what I'm supposed to do. I'm gonna let you guys do this and this one. So, we have... I gotta color code. Or just color code. Okay. Using the form, we're going from here to here. And how we do that for this problem? Very simple. X 1/5. Color coding. I think there's a trick to this. I think I gotta like, don't go too hard so it doesn't bleed, but it's still kind of bleeding because this one I pressed too hard and it kind of made the 3 kind of rub against, but yeah. Okay, this is a 5. Okay, now, okay, here's a thing. Remember how we had an implication over here? I think of, whenever I say implication, I always think of It's Always Sunny in Philadelphia. I'm not sure if you guys seen that movie, or not movie, the TV show. Okay, you know how I mentioned over here that there's just an implied 2? That's basically what we do. There's an imaginary 2 right there. So, we do x 5/2. Is an imaginary. Okay, we are done with this. Oh man, this is gonna be a long video. Oh, if you guys actually watch this entire video, you are a trooper, because I probably wouldn't even want to watch this. I shouldn't be saying that, but okay. I'm gonna do 8. Well, might as well. Well, yeah, might as do 8. I think we'll no, I'll do it. Because I already did it, and I think I made you guys do this in class, so I think you guys already had it. Oh, I gotta color coding. Okay, I was using the red. Okay, gotta keep it consistent. I don't want to mess it up. Okay, we're using, hold on, sorry. We are going from notice that this is exponential form, which what we have over here, and we want to go to a radical, and it has to be a positive. Or actually, in this case, well, yeah, it has to be radical, and well, and it's gonna have to be a positive. Yeah, you won't be able to write it as a radical unless, yeah, no, there's no, yeah, it's not. I don't think you can do the negative, so yeah, you're gonna have to write it as a positive radical, because I don't think there's such a thing as a negative radical. Actually, that's actually a good question. I should know that. Yeah, I don't think it is. I think that's like a taboo. Yeah, I think that's like a bad. Yeah. Okay, we're gonna have to use this. We have to go from here to here. Notice how we're going from negative v to positive v, and then over here we're going from positive v to negative v. So we keep whatever, we're going from negative to positive, negative to positive. But notice how it's 1 over the actual base with the exponent. So in this case, it will be 1 over a to positive 1/3. Don't forget that it's positive, because we're going from negative. Not sure how I should do this. Yeah, no, I should do that's fine. Okay, positive. We're going from negative to positive. Same thing as what we have over here. Negative to positive. That's what we're going from here to here. Now, we got to change this exponential form to a radical, because it says in radical form. This is equal to, can you get it? There we go. Let me just remind you back here, I'm not going to keep constantly flipping it over. When we have this form, we can switch it from here to radical form. I won't be constantly switching back and forth, because hopefully by then, or the last one, you will know what I'm talking about now. But also notice how I don't put a 1 here. It's implied. You can put a 1, but it's gonna look kind of funny. It's like, I'm pretty sure you guys remember, like when you write down, let me write down side note. From video. Or actually, no, I should actually write it on a separate. Actually, that's actually better. I should have thought of that. Hold on, let me get a piece of paper. Okay, you know how in your other math classes you saw this equation, mx plus b is famous. Pretty sure you guys still remember this. Imagine you have your m is 1 and then your b is 3. Okay, how would you write this down? Well, you replace each one. You do 1x plus b. Well, this kind of looks kind of funny. You can just ignore writing the 1 and just write down this. This is exactly what's happening over here. It's exactly the same thing. It's not wrong if you put 1x, but you know, you could just simply just write down x, because there is an implied 1 in front. So that's just a little side note. Oh, I'm shaking the camera. Oh, hope I didn't make you dizzy. Okay, now change it to a positive. I'm going from here. Remember the formula, we're going from negative to positive, but we're doing it 1 over. Okay, so it's going to be 1 over. What is that? Is that 4? Yeah, I hope that's 4. Even I can't even read it now. Damn. Okay. 1 over a to the 4th fifth power. There you go. I was about to say just to the 4th, but or I was gonna say 4 divided by 5, but that's kind of weird to say. Or the 4 divided by 5 power. Usually you would say a to the 4/5 power, but you know. Okay, now we want this in radical form. Remember, radical form. This is gonna be, or I should actually label over here. Oh, I hope I didn't mess that up. Oh, I messed it up. I should really like do dashes so you could still see it. Yeah, I should do that. Okay, well, it's going to be 1 over a 5 and a 4. There you go. I hope, let's see, this is a 5. Oh man, this is going to be horrible. Probably should have color coded, but sorry, getting a message. Okay, sorry. getting a text message. Sorry, that's why you were hearing the buzzing. Okay. Now we're going to be doing these problems. Number 9, evaluate the following. Okay. We are doing negative exponents and also positive exponents. So, usually you don't write negative exponents, you usually write it as a positive. So, I'm just gonna, first we're gonna be using a lot of rules at once. I should label them. I should really label them. I should say rule what? But then, well, some people use it. Okay, I'm just gonna say a rule, and then we're gonna, like, if you have any questions, just let me know during class, or just look at your previous, or pause the video, and then go back and then see what rule that we're using. Okay, so we're gonna be using a rule right here. We're making this exponent a positive exponent, and then we're squaring this 9, which is 1 over 81, because 9 times 9 is 81. Okay, now we are doing this rule. We're changing this to, actually it should be just a regular, a 9, square root of 9 is 3. We're going to be using this rule. We're flipping it. Positive exponent. And then now we're going to do square root of 9. Oh man, sorry. I am like, this is even worse than actually in the class. Because no one can call me out on it. Yeah. Yeah, if I ever make mistakes on, like, if you can't see, especially on the board whenever I'm in class, yeah, just call me out. But, hey, I can't really say the word, but you are messing up. And here we go. Okay, now here we go. This is gonna be a trick. I should actually I should actually designate certain problems. Let's do, okay. Let's do F. And I, those are the two problems. Okay. I was looking at the problems. I wanted to see which one I wanted to do. Or actually, no. I want to do nat or G. Yeah. There you go. Okay. Now, when you don't see a parentheses around this exponent, like for that number, you're only doing it to this number. You're not doing it this. You're not doing this. This is not what you do. See, this is the square root of negative 9. No, this is not the same thing. This is this. You're only squaring the 9. The negative part is outside. I'll show you an example of what that means later on. But okay, what is square root of 9? It's 3, but we have a negative, so it's a negative 3. Over here, we're doing squaring. Squaring the 9, but we're not squaring negative 9. So, we're only doing 9 squared, and there's a negative. So what's 9 squared? 81, but there's a negative. So it's just simply 81, but it's negative 81 because we still have that negative sign. Okay, now we're gonna go back from here to here, or actually here is actually a better representation. Okay, now we have to do negative 9 times negative 9. this becomes 81. That's what we did. Okay, now over here, we have an issue. We have not only an exponent, but we also have a negative exponent. We gotta first swap it. But remember, this is the negative 2 exponent is only talking about the 9. So it's not talking about this negative sign. So we're doing negative 1 over 9 squared. We change this negative 2 to a positive 2. And then this is negative 81. Okay, I hope you guys follow along. Actually, I should write down the negative 81 right there. And then that negative 3 right there. Okay. Now, right here, or which one did I, I was supposed to, I was supposed to give you guys this. And I still did. Okay. Okay, and I still did this too. Okay, I guess we're doing I and let's do this. I and L. Okay, I gotta make sure I don't do that. I gotta cover that. God damn it. Okay, we got a negative exponent, and then you see how there's parentheses? We gotta do the entire thing. It's negative 9. We're doing the exponent of negative 2 to negative 9. Okay, so it is gonna be negative 9. Remember, we're swapping the negative exponent to a positive exponent. We're still keeping that negative 9 because it's inside the parentheses. Okay, what's negative 9 squared? That is 1 over 81. You got that? Okay. I gotta move through because this is gonna be a long video. Damn. Okay. Okay. Remember, this is see how there's parentheses? That's key. So we're doing this exponent on this parenthesis or on this number inside of the parentheses, which is negative 27. So we got negative 27. I'm gonna do the radical, and then I'm gonna use that trick that we learned in the previous rule, doing the exponent outside, so it makes it easier. So, and then the index is 3. 3. Yeah, I should not even label. I should have color coded. I think I just messed up everything when I was doing this. This looks horrible. Yeah, it looks horrible. Well, I tried to do something good, but it turned out really bad. I hope you just follow along with my explanation. And I hope also the pictures actually do better. But anyways, okay, what's a number when you multiply with itself 3 times gives you negative 27? That number is negative 3. But we still have to square it. What's negative 3 squared? The entire thing, the number is negative 3. So you're doing negative 3 times negative 3, which is 9. Okay, don't do this part. I gotta keep remembering. Okay, so we have a negative exponent, and we need to first make it positive. So we go 1 over 27, and then what's the exponent? 2/3. We're changing it to making a positive. Now, we switch it over to a radical, which is, the index is 3, 27, and then I'm going to square. What we did, if you multiply a number 3 times gives you 27? Well, it's 3. This is just like the same thing, but it's negative. But in this case, in this case it was a negative. In this case, it was positive. So we got 3, and then we got to square it. So it's going to be 1 over 9. There you go. This is the answer. Actually, I should box all the answers. You will see all the answers boxed. You want my life to be easier for grading and me not making a mistake? Box your answers. Okay. Now we're doing the backside. Okay, we are gonna be doing, I'm pretty sure you guys done this with Miss Lamb, these exponent rules. Here we go. Let me actually just cover so that they don't dry. I don't want my highlighters to dry out. Okay, these are the rules. We'll give you a second to look at these rules. Notice the patterns. Okay. If you need more time, just pause the video. Okay. We are using this rule, the same base. We're just simply adding these exponents. Why? Because we have the same base. So we're adding these fractions. It is 4 1/3 plus 1/6. And now you gotta find the fraction, the least common multiple, and combine these fractions. Now we can rewrite 1/3 as 2/6. This is still the base is still the fourth. The 1/6 is still the same, and then 2/6 plus 1/6 is 3/6, which is simply 1/2. What's this in radical form? It is the square root of 4, which is 2. I hope I did not lose you. Okay, first let me just reiterate. Okay, we got 1/3 plus 1/6. That's how we use this rule right over here. And then 1/3 is the same thing as 2/6. We multiply the top and bottom by 2 because we wanted the same base, or the same denominator, not the same base. The bases are the same over here, but I misspoke, sorry. The same denominator because we're adding the fractions, and you need to have the same denominator in order to add these fractions together. So we got 2/6 plus 1/6 is equal to 3/6. 3/6 is the same thing as 1/2, and then we change this as an exponent. We change it to a radical, which is the square root of 4, and the square root of 4 is 2. Okay, now this one. Okay, here we go. We are doing this one. Okay, we're going to be using this one. This is the rule that we're going to be using for the exponents. Or actually, it doesn't actually explain it. Oh, wait, oh no, whoops. I was like, well, where is it? Oh, okay, this is, I was like, oh, I just saw it. I was like, sorry, I was like looking at the other monitor. I was like, I was pointing at the wrong thing. Yeah, no, we're using this rule, sorry. We're using this rule. Notice how the same base, and then we're doing u minus v. The top exponent minus the bottom exponent. So, we have the base is both 8, so that's good. Okay, we got 1/2 minus 1/6. Okay, 1/2. That's the same as if you were to do 3/6, right? 3 out of 6 is still 50%, and then 1/2 is 50%, so it's the same thing. What do? We multiply 3 by the top and the bottom of this fraction right here. Why did we do that? Because we wanted the same base. We wanted the base, or not the same base, the same denominator. Damn, I made that same mistake twice now. That's not good. It's okay to make mistakes though, as long as you correct it and learn from it. In this case, I didn't learn from it, so hopefully by the second time I learn. But anyways, okay, we got 3 over 6 is the same as 1 over 2. Okay, now we can subtract these exponents. This becomes, okay, what's 3 over 6 minus 1 over 6? Okay, well 3 minus 1 is 2. 2 over 6, well that could be simplified. That is the same as 1 over 3. Okay, and then we change this to a radical. It is the cube root of 8. So we got to find a number when you multiply it with itself 3 times gives you 8, and that number is 2. Oh, I should. Okay, I'm gonna let you guys do this. Do this problem. So I gotta make sure I give you guys problems. Okay, I'll give you guys this one. I'll do these two. Okay. Now we gotta first. Okay, it says express each radical in exponential form and then apply the rules of exponents. Okay, so first change this to the radicals, or change it from the radicals to the exponential form, and then we gotta use these exponent rules. Okay, we have, this is an imaginary 2, and there's a, there's always a, well, it's not an imaginary because it is a 2 there, it's just implied. There's a 2 right there and there's 1 right there. Look back in knowing the rule that we're going to be using. Okay, so this is x times this radical, or the square root of x. So this is x times x to the 1/2. This is a rule. We went from here to here. This is a rule that we did on the previous problems. Okay, there's a 1 here, exponent. Okay, now we got to use this rule, combining the exponents. We got the same base. Okay, so we got x 1 plus 1/2. This is the same thing as writing 2 over 2 plus 1/2. This is the same base. And then we have 2 plus 1 is 3. 3 over 2 x. So this is your answer. X to the 3/2 power. And you just, yeah, you can write it, yeah, just write it like this. That's all you need to do. Okay, now we got multiple rules over here. Okay, we got, okay. Change this to an exponential form. This is, looks like a 3. Yeah, it looks like a 3. Okay, so this is a 3. Okay, so change this to exponent. So we're going to be using a rule 1 over 3. Okay, we got x squared divided by x over 1/3 power, and then we got to use a specific rule, which is this rule right here. I know there's a bunch of rules that we're going to be doing. It's not the most exciting, just rules and rules. Okay, so same letter, 2 minus 1/3. Okay, this is the same as if we were to do x and then 6 over 3. 6 over 3, that is just 2. So I'm just rewriting this 2 as a fraction so we can subtract it. So 6 over 3 minus 1 over 3, that is x 5 over 3. That's it. Okay, I'm gonna let you guys do this, hopefully, because making a long video, I gotta make it go faster because I'm getting tired. And I'm pretty sure you guys will not watch this, but if you have watched this, thank you. Okay. We are solve for x. Okay. We are doing, okay, we're going to be doing these specific rules. Okay. I'm going to rewrite this so it just makes it easier. Okay. We have x to the 3rd half power equals 8. The first thing you got to do, square both sides, not square root. I was about to say square is not square. Square both sides. Why are we doing this? Because because when you multiply this out, I think there's a rule right here. Yeah. When you multiply it out, in this case it's a fraction. But it's you're using the similar rule. So 2 divided by 2 is 1, so all you're left with is x to the third power. But whatever you do to one side, you have to do to the other side. Okay? And then what is 8 squared? That is 64. Okay? Then we have to cube root both sides. When you cube root a cube, it becomes a 1. It cancels out, actually. They're basically inverses of each other. And then what number, when you multiply with itself 3 times, gives you 64? Let's try that out. Let me just do, okay, does 3 work? 3 times 3 times 3. Okay, no, that does not work. Okay, let's try 4. 4 times 4 times 4. Look at that. We got 64. So x is simply 4. Okay. Another way that we can do this is multiplying by the reciprocal and raising that to the exponent. This is one way of doing it. This is a longer process. And then this is another shorter way. This is 5/3. So you multiply, or you raise it to the reciprocal exponent. The reason why you would do that is, watch. You do, instead of it's 3 over 5, you do 3, or 5 over 3, you do 3 over 5. You raise that. Because if you do 3 divided by 3, that is 1. 5 divided by 5 is also 1. So you're left with x, just simply x. But whatever you do to one side, you have to do it to the other side. So you have this. So x is equal to negative 32. Okay. But we gotta solve for x. Okay, let's figure this out. Okay. We could use our knowledge from the other problems that we did to solve this. This becomes switch it to a radical. I suggest you do the radical first and then the exponent. Sorry, I burped. This is what we did in the previous problems. Now we're adding a lot of information now. Okay, what's a number when you multiply with itself 5 times gives you 32? The answer is -2. And then you raise it to the third power, which is, what is -2 to the third power? It is -8. So x is equal to -8. Okay. Let's see. Oh, this looks kind of funky. Okay, well, okay, in this case, I'm gonna do this. I should let you guys do problem. Yeah, I'm gonna let you guys do these problems. Okay. Okay, what they did right here, from this step to this step, it's blocked out. They multiply it by the reciprocal of the exponent, which is 4 over 3. Because the original exponent was 3 over 4, so the reciprocal, which is, you flip it, it is 4 over 3, because 4 divided by 4 is 1, and then 3 divided by 3, it is 1. So whatever you do to one side, you have to do to the other side, so it's 4 over 3. So this not cancels out, but it becomes a 1, so you're just left with x minus 1 on that side. And this side becomes 64 4/3. Now, we got to write this in a radical. It's kind of blocked out with work, but I'm going to write it over here. Okay, we have simply first do the radical, then the exponent. Okay, what's a number when you multiply it with itself 3 times gives you 64? We actually kind of already did this. Right above it, it's actually 4. Sorry, it's kind of messy right now. Hope you guys follow along. If you guys have any questions, I can just explain it to you in class. Okay, so we got 4 raised to the 4th power. What's 4 to the raised to the 4th power? Well, I know 4 to the 3rd power is 64. So we just need to do another 4, and that is 256. Okay, now, but we got, ignore this. We got x minus 1 equal 256. And then we just, it's a simple equation. Add 1 on both sides. So x is equal to 257, which is, that's what we got. Okay. And in this case, this is just an exponent. How you basically you have to do the inverse. The inverse of an exponent is doing square rooting. In this case, it will be the square root of the 7th square root. In this case, it's like this. When you 7th square root a 7th exponent, they become 1. They're inverses of each other, so they don't cancel. No such thing as canceling. They undo each other. So all you're left with is just an x. So you go from here to here. Now all you're left with is this. Now you can't really, there's no perfect number when you do this like calculation. There's no number when you well, there is a number, but it's not going to be like a solid number, like, oh, it's 4, or something solid like that. It's going to be decimals, and it will most likely go on forever. So in that case, if you can't do it, then just leave it as is. It's really fine. And then I'm going to let you guys do E and then F. Okay. I'm going to let you guys have fun with, so let me just write down the numbers and letters on my notepad so you guys know which problems that you are going to be doing. You are going to be doing problem 5 on the worksheet, and then F and G. And then problem 6, you guys are doing C and F. And then you did all that. On problem 9, you guys doing, I hope you guys don't get offended whenever I say you guys. It's just like I don't mean anything by it, it's just a slang term. I should really shouldn't be using that, except whenever I talk to my friends, but I gotta be more professional because I am the teacher. I gotta be professional, and all that. Okay. And then problem 11C, and then problem 12C. Okay, I'm writing all this down. And then problem 14E. These are your homework problems. I will not make this homework due tomorrow, since I put it so late, and sorry about that. So I'm gonna postpone it, and it's gonna be due on what is today? And we meet on tomorrow. That's pro hour, and then we meet on the 19th and then the 21st. So we're gonna make this due on the 21st, and then this is gonna be homework 3. So these are gonna be the problems. Okay. I will leave it at that. I should make this L a little bit more like an L, I guess. It's not a capital L, but you know, you get the point. So we have, you got to do the packet, the worksheet, and then the homework is these problems, and then you will have to do this homework, the point slope, and that's going to be due on Thursday as well. I'm going to make an extension because I was kind of late on for you guys. Sorry about that. I'm still getting situated. And then this is, I said for this is extra credits. So this thing is just going to be extra credit for homework 3. So I'm going to, it's not going to be crazy. Like you're not going to get like a crazy, or like, well, it's probably going to give like, say that it's out of, the homework is going to be out of like say 20 points. And then you get, maybe for this case, if you do this entire thing and then don't get anything wrong or whatever, 100% correctness, you'll get 10 extra points. So you're going to get basically 30 points out of 20. So that's how I think I'm going to grade it. Or if it's not 20 points, if it's a different ratio, if it's like, say that it's 10 points, what the homework is going to be out of, then you'll get 20 points out of 10. So it's going to be that ratio. It's going to be, or no, it's going to be 15. This is going to be 5 points then, because it's 50% of whatever the points that you will get from the homework. Not 20. What am I doing? Doubling. But yeah, okay. If you watch all of this video, well, thank you. But hopefully I'll make my videos a little bit faster next time. This is my first time for doing this for this class, and I haven't done it in a while. So this is a learning process. I hope you guys can read all this, you know. But yeah, let me know if you have any questions. You can go, you know, I'm in room 452 most of the time, and I'm there most of the time at during nutrition break and lunch, and a little bit after school. But if you need me to stay a little bit, you know, I'm not guaranteed always to be there, but usually maybe moving around. Maybe I'm doing last minute, maybe I'm in the copier machine, or like over in the like doing the Xeroxes and, you know, making copies. But if you need any extra help, let me know. I'll meet up with you. I'll be happy to help. I'm here. Okay. Hope you guys have a good evening, or whatever, or afternoon, morning, or whenever you're watching this.